Hello students, in this lecture we'll drive expression for curl of a vector point function in orthogonal curvilinear coordinates. So let's drive this expression. Let a vector in whose order triplet are u1, u2, u3 is a vector point function in orthogonal curvilinear coordinates u1, u2, u3 which are continuously differentiable. uh, and if u is a function of u1 to u3 and let it be in the let vector a is represented by a1 e1 unit vector plus a2 e2 unit vector plus a3 e3 unit vector. This is a position vector of a point in the curvilinear coordinate where a1 a2 a3 are the components of a vector in along E1 vector, E1 unit vector, E2 unit vector, and E3 vector means along the tangential unit vectors to the curve. One U2 respectively. Now we wish to find curl of a vector. Curl of a vector means how is the del cross a vector. Now substitute the value of a del cross a. When del is operated on this is equal to del cross first component plus del cross second component plus del cross third component. Now we'll solve this first component and similarly other two components will be substituted. So now del first component is del cross a1 e1 vector. Now it is del, so it can't operate upon e. So we have to convert this unit tangential vector into unit tangential vector to a curve u1 to unit unit tangent to a normal vector to the surface as well. From this with the help of this relation, del of ui is equal to vi upon hi horizontal. So substitute value I here. This will be equal to e is equal to h e1 is del e1 is equal to del of h1 del of u1. Now you have to convert it into del because this del operator can't operate upon this, so we have converted into normal vectors, the surface as well. So tangential to the surface u1 and converted to normal vector to the surface u1. Now this is scalar point function and say vector. Fully operated if I gradient of a scalar point function, you get a vector function. This is scalar. So now this term is meaningless. The cross product is meaningless. The scalar, we can find cross product two vectors. Del vector is a cross vector and this is a vector. Appropriate del operator on a scalar point function, that is vector. So we know the theorem del cross psi of f. This is del cross psi of f vector is equal to del of psi cross f vector plus psi del of f vector. Now substitute this value here. This is psi a1 h1 psi del of u is a f vector. So del of psi del of a1 h1 cross del of u f vector plus psi del a1 h1 del cross f vector is del of u. Now we know that uh, gradient of curl of gradient of phi is 0. So this is curl of gradient of u1 scalar point function is 0. So this value is 0. So we are left with one component only. This is equal to del of a1 h1 cos. Now substitute the value back here. Value back and del is equal to u1 upon h1 equal to u1 upon h1. Now we know that del operator, substitute value del here, operate this del operator on this scalar point function a1 h1. So del is this, del in the current coordinate is equal to e1 upon h1 positive is to u1 plus e2 h2 positive is to u2 plus u vector e3 h3 positive u3. Substitute the value here and operate it upon h1 u1 h1 sorry h1 a1 h1. So h1 5 h1 h1 cross u1 upon h1. Now, now these are vectors in current coordinates. So e1 into e1 is equal to 0. So this component is 0. Now e2 into e1 is equal to minus e3, and this is h2 h1 h2 and partial derivative of is to u2 of a1 h1 plus e3 cross e1 is equal to e2 cyclic order plus cyclic order is equal to h1 h3 partial derivative is u3 a1 h1. Similarly, we can write this is the uh, del cross a1 e1 comes out to be how much? This is e1 vector upon h1 e2 vector h1 h3 partial of h1 a1 h1 is to u3 minus e3 vector upon h1 h2 partial of a1 h1 is to u2. Similarly, we can write del we can curl of a2 e2 vector. Similarly, similar step. This will be equal to e2. This is equal to e3 cyclic order e3 upon h1 h2. Now this is e3 e2 e3 e1 cyclic order. This is e3 e1 e1 e3 upon h1 h2 positive u1 of a2 h2 minus this is e3 e2 is here. This would be e3 e1 e1 e2 e3 e2 e3 e1 e1 upon h1 h2 h3. So positive this u. So you don't have positive in this. You don't have positive. This is u1 e2 e3 u1. This is e1 e3 u3 and u1 and similarly cyclic order and this will pass in the curl of a1 e3 h a3 e3 is equal to e3 upon similarly e1 e3 is equal to e1 upon h2 h3. The first cycle order is e1 e2 u2 u2 3z u1 is that first derivative of u2 of a3 h3 minus e2 minus e2 e3 e1 u upon h1 h3 positive u1 a3 h3. Now substitute these values in this. Substitute these values in this value in equation A. After substitution these values, we got these terms. This term, yes. Now multiply by h1, divide by h1, multiply by h2, divide by h2, multiply by h3, h3, and 1 upon h1, h2 is common. Now convert it into determinant form. In order to remember this result, curl of a vector is equal to this equal to e1 h1 e1 into vector. And this is equal to how much? Positive u2. This into this. Positive to u is to this minus positive of a2 h2 is to u3. Plus is here minus take will be taken outside. Minus outside this will be this will equal to e2 h2 h2 and this will be positive of this minus common, so this minus this. So positive of u2 with this of this minus positive of uh, a2 a1 h1 is to and so on. This will be so curl of a vector will be in the current coordinate system. So 1 upon h1 is plus 3 to h1 total h2 equal to h3 is total passing u1 u2 u3 a1 h1 a2 h2 a3 h3. So this is where a